Hello everyone, welcome to Renaud Talks IP. Today we'll talk about transparent clocking versus boundary clocking. So let's start with the basic. The PTP. So what's the PTP? It's the Precision Time Protocol, and we'll have two masters inside our network, but I will come back to the master in a few seconds. So the PTP will be sent to devices for synchronization, and also it's used to timestamp the packet from a sender to a receiver. The goal is to resynchronize inside the receiver as well. So, and do clean switch because you need a reference. It's kind of our black burst in an SDI mode. In the SDI world, you will have black burst. In network, you have the PTP for 2110. So how this works, I just said there's two masters. So there's master A and master B. They will be what we call the best selection of grandmaster. So we'll start with the identifier, the quality of the master, the priority, and the variance of the clock. And then we can establish which one is the best. If they're both the same, there's also an identification inside the grandmaster, and we'll pick the one that is prioritized between the two. So then when the grandmaster is selected, so the grandmaster will start exchanging with the device. So the PTP grandmaster will send the sync signal to the device. The device will come back and send a delay request, and then the slave device will receive a delay response from the grandmaster. So there it's used to calculate the time in the network and basically adjust the time inside from the PTP received. So usually it's done 8 times per second in AES R16 profile. Profile can change and you can go to 16 times per second, but this is really in the 2110, it's 8 times per second. In the case of the MeteorNet IP product, this can be changed. So type of messages. So messages is changed, like I said, from the grandmaster to the device itself. And it can be multicast, unicast, or it can be hybrid. Meaning that all the exchange can be in multicast, exchange can be in unicast from 1 to 1, or it can be hybrid. So the sync is sent to multiple slaves, and then the master receive a unicast from all these slave devices. So let's talk about transparent and boundary clock. That's the reason for this video, right? So transparent clocking means that the grandmaster will talk to all the devices. So think about a student and teacher approach. The teacher will talk to thousands of students. So you can look at this as a big room. And sometimes the message from one to the other, it's kind of like in the noise, and it could be delayed when everyone requests a question to the teacher. So the boundary clock aspect is really interesting. It's instead of having one teacher that talk to all 1,000 students, you will have one grand teacher, let me call it this way, that will talk to different teachers, and then they will go talk to their class. So instead of being 1 to 1,000, it will be 1 to, let's say, 20 teachers. And the 20 teachers will talk to 20 or let's say 50 students. So then you covered all your students, the interaction is faster, and the grandmaster will communicate the clock to the switch. So how this is done, it's basically the grandmasters talk to switch, let's say the leaf switch. The leaf switches are their slave to the grandmaster, but they're master to the device connected to them. So again, slave with the grandmaster, so grandmaster communicate with them. The switch itself will be a master to all the devices connected to the switch. So in that case, you will minimize all the delay, communication, like delays of packet, because you don't talk to all the grandmaster, but you talk to your local switch. So the takeaway of this is edge device will talk to a grandmaster. It could be the switch or it could be the grandmaster itself. If you want to scale up, we do recommend that you use boundary clock, so then the device will talk to a switch. So I guess the takeaway of this, so boundary clocking will scale way better than the transparent clock. So thanks for watching. Please, if you have any question, feel free to send it to my attention or add a comment in my video. So thanks again for watching. For more information, visit Renaud.net. Thank you.